Hello everyone. In today's video, let's try to solve an equation that contains both radical expressions and exponent expressions. Here comes the question. 4 to the x power equals x times 2 to the x power plus 1 plus the square root of 2 to the x power minus x. When we see this type of equation, we note that both the exponent expression and also the radical expression are not easy to handle. A common way to deal with it is to do substitutions. And here, we decide to do two substitutions. In detail, the square root of 2 to the x minus x can be substituted with m, and 2 to the x power can be substituted with n. And from those two equations, we can get the expression of x, which is equal to m minus m squared. And then the next step is to substitute x with m and n in the original equation, which leads to n squared equals m minus m squared times m plus 1 plus m. The right side of this equation can be further unfolded, and we note that both left side and right side contains n squared, which can be cancelled, which leads to m squared times n minus n plus m squared minus m equals 0. And we note that the left side polynomial has a common factor of m minus 1, which will be very useful for us. And after a few steps of manipulation, the left side can be written as m minus 1 times mn plus n plus m equals 0. We note this equation as equation number 1. By the definitions of m and n, it's easy to find out that m is no less than 0 and n is larger than 0. That means mn plus m plus m is larger than 0. Therefore, the equation number 1 is equivalent to m minus 1 equals 0. And in other words, it means 2 to the x power minus x minus 1 equals 0. Let's note this equation as equation number 2. To solve this kind of equation, we need to do some derivative test. First of all, let's constitute a function f(x), which is equal to 2 to the x power minus x minus 1. It's easy to find out that f0 equals f1 equals 0. That means 0 and 1 are two solutions to equation number 2. But we need to check if those are the only two equations. From the expression of f(x), 2 to the x power minus x minus 1, the first derivative is 2 to the x power ln 2 minus 1, and the second derivative is equal to ln 2 to the squared times 2 to the x power. We note that this is a value that's always larger than 0 for any x that belongs to real numbers. So what does that mean? That means f(x) has at most one local extrema and at most two 0 points. In fact, this is how it looks like of f(x). So we already know that 0 and 1 are the two 0 points of f(x). So that means 0 and 1 are the only two solutions 2 to the x power minus x minus 1 equals 0, and the only two solutions to the original equation. And this problem got resolved. Thank you for your listening.